Hello and welcome to the Pedagogic table. Magnesium was discovered in 1755 by Joseph Black. The name originates from the Greek district Magnesia. Magnesium is a light, silvery white, relatively tough metal. It tarnishes slightly in air, and finely divided magnesium ignites upon heating in air, burning with a bright white flame.
Okay, so we're now going to look at magnesium metal. Now magnesium is a group 2 metal. It has 2 electrons in its outer shell. Before we looked at sodium and potassium, which were group 1 metals, they had only 1 electron in the outer shell. Group 2 metals are actually a little less reactive than group 1 metals, but still some of their reactions are quite impressive. One of which is when magnesium burns in oxygen and makes magnesium oxide, MgO. Now this reaction is very, very common in schools. It actually shows that magnesium burns with a very bright, intense flame. So bright, in fact, that you shouldn't look straight into it. It's also used, this reaction, to make fireworks and also used in making distress flares because of the brightness of the flame. So we'll show this reaction by putting the burner on, turning the lights off, and we shall then observe magnesium burning in oxygen.
Magnesium is the 8th most common element in the Earth's crust. It is not found free in nature, but it is available in minerals such as dolomite and magnesite. It is also found in brines and seawater. The most common way of obtaining magnesium is through electrolysis of fused magnesium chloride, which is derived from its natural sources, brines and seawater.
Okay, so what we're going to do now is we're going to do a second investigation of magnesium. Now magnesium burns with such an intense, strong flame that actually it will burn not only in oxygen, but actually it will burn in an atmosphere of carbon dioxide, CO2. And what you get is magnesium oxide as before, as when magnesium burns in air, but you also get solid carbon. The magnesium pulls the oxygen from the CO2, leaving solid carbon, which you'll see on the walls of the container. So the first thing we have to do is we have to fill the container with CO2. So I have a CO2 canister here, and I simply need to place it into the bottom of the gas jar here and fill it. CO2 being more dense than air will actually fill from the bottom up and actually just reach to the top and spill over. We won't see that, but if we just leave the carbon dioxide on for, say, 30 seconds, we can be sure the gas jar is full of CO2. So now the gas jar is full of carbon dioxide. I can hear the gas coming out. I'm sure now the gas jar is actually full of CO2. So if I turn this off, the CO2 will stay inside the container since it's more dense than air. Now what I'm going to do is the same procedure as I did last time. I'm going to light the burner. The magnesium needs to be started off in air first, and then we'll quickly plunge it into the atmosphere of CO2. First of all, we're going to light the burner if we can. Here we go. I have magnesium again, this very soft metal. What I'm going to do this time is I'm actually going to wrap it around this little spoon I have. And what we need to do is we need to catch it on fire. And then we're going to plunge it straight into the jar here of CO2. So we'll get it burning first. When it's burning nicely, we'll plunge it into here. And you saw there it burning within the atmosphere of CO2. If we take it out, you can actually see the magnesium is fully combusted, making magnesium oxide. And you see there is this cloudy coating on the outside of the container. This is actually carbon, solid carbon.
For 1,000 years, magnesium has been used worldwide in pyrotechniques because of its spectacular flame. It is also used in alloys, creating light metals that are easy to weld.